Hello, today we'll be explaining the life cycle of a star. First off, we have a small ball of gas. Every star starts inside a cold cloud of hydrogen gas and dust in space. Over time, gravity pulls this gas together into a small tight ball. As the gas compresses, it gets hotter and hotter. Once the core reaches a high enough temperature, nuclear fusion ignites and the star is officially born. Next off, we have main sequence star. This is the longest and most stable phase of a star's life. During this time, the star fuses hydrogen into helium in its core, releasing a constant stream of energy and light. Our Sun is currently a main sequence star. It stays stable because the inward pull of gravity is perfectly balanced by the outward pressure of nuclear fusion. The third stage is a giant. Eventually, the star runs out of hydrogen fuel in its core. Without fusion to fight gravity, the core collapses and heats up even more. This intense heat causes the outer layers of the star to expand massively and cool down, turning it into a red giant. After a giant, we have supergiant. Stars that are much larger and heavier than our Sun go through an even more extreme expansion. They become supergiants. These are some of the largest stars in the universe. Because they are so massive, they burn through their fuel at a furious pace, fusing heavier and heavier elements like carbon and oxygen to stay alive. Next, we have white dwarf. For average-sized stars like our Sun, the giant phase ends when the outer layers gently drift away into space. All that is left behind is the dead, hot core. This is a white dwarf. It is about the size of Earth, but incredibly dense. It no longer produces energy. It will just slowly cool down over billions of years. After white dwarf, we have a massive explosion called supernova. Massive supergiants have a much more violent end. When their core tries to fuse iron, it runs out of energy completely. The star collapses in on itself in a matter of seconds. This collapse triggers a massive explosion called supernova. The explosion is so powerful it can briefly outshine an entire galaxy and blasts heavy elements out into space. Next, we have a neutron star. If the core left behind after a supernova is heavy, but not heavy enough to form a black hole, gravity crushes the remaining material into an ultra-dense ball of neutrons. This is a neutron star. It is only about 10 to 15 miles wide, but a single teaspoon of its material would weigh billions of tons. We also have pulsar. A pulsar is a highly magnetized, rapidly spinning neutron star. As it rotates, it shoots intense beams of radiation out from its magnetic poles. Because it spins so fast, these beams sweep across space like a cosmic lighthouse, creating a highly regular tickling signal that can be detected from Earth. If the dying star was exceptionally massive, nothing could stop its final collapse. Gravity completely wins, crushing the remaining core down onto an infinitely small point. This creates a black hole. Its gravitational pull is so powerful that nothing, not even light, can escape it once it gets too close. To summarize, here is the whole life cycle of a star. First, we have the small ball of gas, which is the first stage. Then we have main sequence star, which is the current stage of our Sun. Then we have the giant, then the supergiant. After the supergiant, we have white dwarf, then supernova, then neutron star, then pulsar, and finally a black hole. Okay, now let me ask you questions. What stage is our Sun going through right now? Correct, a main sequence star. Okay, now for the second question. What is the main fuel that stars burn during most of their lives? Correct, the answer is hydrogen. Thank you for watching.